Good day everyone. In this video, we are going to talk about photoelectric effect. This is Leo Senelio from BSc Science 3A. What is photoelectric effect? It is a phenomenon in which electrically charged particles are released from or within a material when it absorbs electromagnetic radiation. So the effect is often defined as the ejection of electrons from a metal plate when light falls onto it. Alright, so we have here the Einstein said that the energy of a photon is equal to the minimum energy needed to remove an electron plus maximum kinetic energy of the emitted electron. So we have here different formulas. As a general photoelectric effect, we have here the HF, or the Planck's constant multiplied by the frequency, or it could be H, but it is already V, but it is used in this equation. F is being used, is equal to work function. This is a symbol of work function plus the kinetic energy, the maximum kinetic energy. Alright, so now we have to solve our two problems. First problem, we have here, given the work function, or this is the symbol of work function for selenium, is a 5.10 electron volts. So our task here is to find the frequency that is required to emit photoelectrons from selenium. Now let's identify first the given values. We have the given of work function, that is 5.10 electron volts, and the Planck's constant, that is 4.14 times 10 raised to the power of negative 15 electron volts per seconds, or that is equal also to 6.626 times 10 raised to the power of negative 34 joules per second. So it is already this is already converted to electron volts, and what our task here is to find the frequency, or that is small letter f. And alright, so now let's plug in our equation, that is HF is equal to maximum kinetic energy plus the work function. So solution, we have here, substitute all the given values. H value, we have here 4.14 times 10 raised to the power of negative 15 electron volts per seconds. And F here, the frequency, is what we are going to find. And the kinetic energy is 0. The maximum kinetic energy is 0. And our work function here is 5.10 electron volts. And now let's cancel out same units. We have here electron volts. And in order to cancel out here the 4.14, in order for us to find our frequency, let's multiply both side by 1 over, or 1 divided by 4.14 times 10 raised to the power of negative 15 seconds. And now we have here also here and cancelled out, so that frequency is equal to 5.10. This is 5.10, and 4.14 times 10 raised to the power of negative 15 seconds, and 5.10 divided by 4.14 times 10 raised to the power of negative 15 seconds is equal to 1.23 times 10 raised to the power of positive 15 hertz, or 1 over s, or 1 over second. So 1.23 times 10 raised to the power of positive 16 hertz is the frequency that is required to emit photoelectrons from selenium. Alright, so let's move on to our second problem. We have here a light with a frequency of 4.5 times 10 raised to the power of positive 16 hertz is utilized to illuminate the selenium piece. So our task also here is to find the maximum kinetic energy of the ejected photoelectrons. Alright, so now let's identify the given values. We have the frequency, given frequency of 4.5 times 10 raised to the power of positive 15 hertz. And our Planck's constant, or letter H, is equal to 4.14 times 10 raised to the power of negative 15 electron volts per second. And our task here is to find the maximum kinetic energy. So equation here, we are going to use our HF is equal to maximum kinetic energy plus work function. Now let's substitute all the given values. We have the H here, 4.14 times 10 raised to the power of negative 15 electron volts times a second. Alright, so we have here the frequency of 4.14 times 10 raised to the power of positive 15, 1 over s, or 1 over seconds, is equal to the kinetic energy. Our maximum kinetic energy here is unknown. That is what our task is going to find. And positive and plus the work function, and given the work function of 5.10 electron volts. Now, in order to cancel out, or in order to find, the maximum kinetic energy here, let's transpose the 5.10 electron volts into the left side. So from positive, it become negative. So therefore, we have our maximum kinetic energy of, alright, so we have here, just copy the 4.14 times 10 raised to the power of negative 15 electron volts per seconds multiplied by 4.5 times 10 raised to the power of positive 15, 1 over second, and minus, so now from positive it becomes negative, so minus 5.10 electron volts. Now 4.14 times 10 raised to the power of negative 15 electron volts times 4.5 times 10 raised to the power of positive 15, 1 over s, is equal to 18.63 electron volts times s squared, and minus 5.10 electron volts, so it becomes 13.53 electron volts per second squared, or 1.6 times 10 raised to the power of negative 19 joules. So that is our maximum kinetic energy of the ejected photoelectrons. So that's it. Thank you for watching, everyone.